All right, guys, now we're working on the back of this sheet. So question 3 is another margin of error question. And you can read through it. They ask a poll, and they want to give the results with 99% confidence. So what's weird about this one is they tell us how many people they asked. They said if they survey 750 people, what will be the margin of error? So n is 750. They don't actually tell us what the results are. In fact, you can do this margin of error analysis before you even take the survey. You can know if you give a certain level of confidence and you know how many people you're going to ask, you know what the margin of error should be. Or just sort of so you know how things work in the real world, you can set your confidence level and you can set what you want your margin of error to be, and then that's going to tell you how many people you should survey. And so that's usually how this works in reality. But here we've got 750 people they've asked. So what's the margin of error going to be? So we know what our n is. We don't have our sample proportion, our p hat. Don't need it yet for this. Okay, so 99% confidence, that means we want the middle 99% to be, we want to be confident there, which means we're going to have an alpha, which is 1 minus that 0.99. And so our alpha is 0.01. We take half of it. There's 0.01 total in the tails. So half of that is going to be 0.005. So we have 0.005 there, 0.005 there. And so what we want, we're looking up the z-score for 0.005, which we've done this already. This is for 99% confidence. And we go to our table, and I'm looking in the table for 0.005. So here's 0.052, 0.051, 0.049. So it's right in between these two. And so my z-score for 99% confidence is always 2.57, 2.58. So I do 2.575. That's my z-score. 2.575. Again, don't care about negative because I'm doing plus or minus. So that's my z. My n, of course, is 750. And so my margin of error is going to be the z-score, 2.575, divided by 2 times the square root of n, 750. Make sure we do that in parentheses on the calculator. And when you do that calculation, you get a margin of error of 0.047. Again, before we've even done the survey, we don't know the results. Then we do the results and we get a sample proportion. Our p hat is 0.27. So 27% said yes, they're going to travel abroad. 0.27 margin of error is 0.047. So now we can interpret these results, right? So again, real fast, we'll write this. So first we'll say how confident we are. We are 99% confident, that's a high confidence level, that the true proportion of people who are going to travel abroad this summer, so that the proportion of, what are we looking at? U.S. citizens going abroad is, and now here we go, we do our p hat plus or minus the margin of error. So it's 0.27, 27% plus or minus, this is our margin of error, our wiggle room for our answer. Best guess plus or minus the margin of error. And so we think, we're 99% sure, the real proportion of people who are U.S. citizens who are going to travel abroad is somewhere, should be a 1, between 22.3% and 31.7, 0.223 and 0.317. And then we've asked this before, but it says if the sample size was increased, so n is going up, as our n increases, what would happen to the margin of error? Okay, and so think of it this way. If you have a larger sample, you have more information about what the true proportion is. As your sample size goes up, your sample proportion is more closely approximating the real proportion. You're getting closer and closer to the real one because you're taking a bigger sample. So as your sample size increases, your margin of error decreases. Okay. Another way to see that is the margin of error formula. You have your z-score, and your n is in the denominator. So as this denominator goes up, As the denominator increases, the margin of error goes down. Okay, so that should be decrease. All right, then just some quick stat review. So they give us this data set 3, 0, 14, 5, 1, and 1. And we want to find the mean. So we know our n is 6. We have 6 numbers. The sum of those 6 numbers is 24. And so our mean is the sum divided by n. So it's 24 over 6, which is 4. Standard deviation, this is S. And we have to build a table for this. And so I have to write this super small, but here we go. We've got our different x's. We've got our x minus the mean, and then we've got our x minus the mean squared. Those are our columns that we need for this, and we just list our individual numbers, 3, 0, 14, 5, 1, and 1. You can put them in order, but you don't have to. If they asked us for the median, we would have to put those in order. And then we take the mean, which is 4, each number one at a time. 3 minus 4 is negative 1. 0 minus 4 is negative 4. 14 minus 4 is 10. 5 minus 4 is 1. 1 minus 4 is negative 3 and negative 3. And then if I add those up, they're going to add up to 0. So what we have to say is, wait, I have to square them and then add up the sum of the squares, right? And so square this column, you get 1, 16, 100, 1, 9, and 9. And then add that column up, and you get 136. Just to remind you, it's on the front, but the formula for the standard deviation is you take the sum of these deviations squared, so you add up that column that's squared, 136, divide it. We want to average it out, but instead of dividing by n, we divide by n minus 1, and then the last step is to take the square root. Okay, so for this problem, we've added up that column, 136, divide it by, my n is 6, so I'm dividing by 1 less, 5, and then I take the square root as the last step. And so when you do that, we have to round that off. We get a standard deviation of 5.215. What percent of this data, what percent of those 6 numbers is within one standard deviation? So I'm going to do the mean minus the standard deviation and the mean plus the standard deviation. And I want to say, find that interval, and then what percent of my numbers are within that. So I'm going to do the mean 4 minus the standard deviation, 5.215, and 4 plus the standard deviation, 5.215, 215. And this comes out to be negative 1.215, and this comes out to be 9.215. And so within one standard deviation of the mean, what percent, how many of these 6 numbers are within there? And so they're all in there except for the 14. So we have 5/6 of our data is within one standard deviation of the mean. And so 5 out of 6 is 83%. 83.3% of my data is within one standard deviation of the mean. Last set of questions are just using the z-table. Just saying, here's my z. Can you read this on the table? And the best thing to do is draw a picture for each one of these. So we don't need to calculate z. They've already calculated it for us. We just use the z-table. So here, of course, is the mean has a z-score of 0. I'm at -1. That's the z-score, -1, but I want greater than -1. So I want above that z-score. And so when I go to the table always gives me this area to the left. So I'm going to have to adjust it by subtracting from 1 to get the area greater than that z-score. So I'm looking up the z-score of -1. Here's -1. I go to the very first one, 0, 0. And so I get 0.1587, but I'm going to do 1 minus that. And so my answer that I get, 1 minus 1587, is 0.8413. That's the probability or the percent of a normal distribution that's greater than a z-score of -1. All right, second one, still doing greater than, but now I'm on the positive side of the mean. Positive z-score, so mean has a z-score of 0. I'm over here at 1.09, and I want greater than. So my answer definitely needs to be less than 50%. That's why I draw the picture. So now I'm looking up a positive z-score of 1.09. Here's 1.0 all the way out to 1.09, and I get 8621. Again, because I'm adjusting, I want to the right, and the table always gives me to the left, I'm going to do 1 minus that 0.8621, and I get 0.1479. Last two are a little different. This one I want the percent of the area, or the probability, same question, that are between two z-scores. So my mean, of course, is 0. One of my z-scores is negative 1.58, and one is negative 2.18, and I want the difference between those. I want the area between those. So what I do is I find the area that's to the left of 1.58, which gives me all of this, and then I'll subtract the area to the left of negative 2.18, and it'll give me the area in between, the shaded part. Okay, so what I'm going to do is I'm going to do the probability, probability that z is less than negative 1.58, I'll look that up, minus the probability that z is less than negative 2.18. So I'll look those two up, and then I'll subtract those z-scores. Okay, so negative 1.58, here's negative 1.5, go out to 8, I get 0.0571. Over here, 0.0571 minus, and then I look up that z-score of negative 2.18, go to my table, negative 2.1 all the way out to 8, I get 0.146, and now I subtract them to get the area that's in between, and when I do that, I get 0.0425. Okay, so this area is 0.0571. This area that I subtract away is 0.0146, and the area that's left is the difference, 0.425. All right, last question is this, using the z-table in reverse. So now I know what the area to the left is. I want to pick a certain value so that, pick a certain z-score so that the area to the left is 9357. I want all of this to be 9357. And so the question is, what is that z-score? They call it C in this question. So what should that z-score be to give me 9357 to the left? So now I'm looking in the table, and I'm looking for 9.9357. So I look here, here we go, 9357. And so now I look out of the table to see what that z-score was. 1.52 is the z-score that gives me that area. So 1.52 should be that z-score that gives me that area to the left.